is Jacob Nash with JNGL, and today we are looking at Unit 3, Lesson 3. And as you can hear, I have my stupid ceiling fan on today because it's kind of loud around, and I thought that would block out some of the noise. And this video is on triangular specialties. And I made a specialty font just for this occasion. And let's see here. It's just about like things that can happen with triangles that make special things happen. Okay. I decided to make colored backgrounds on this one. Let me put this up. Okay. Midsegment. This is the first thing. This is a segment that joins the midpoints of two sides of a triangle. Well, that kind of makes sense of why it would be called that. Midpoint, big segment. And then that just makes sense, I guess. Like, that's all that is, really. This red line right here, it connects these two midpoints. And how you know that these 2 points, these two red dots, are midpoints is because of these markings. And there's one dash right there and then 2 dashes there because these aren't equal. These sides aren't equal, but these two measures are. Okay, and then perpendicular bisector. This is already kind of a term that you've learned, but we're talking about it within, like, triangles right now, kind of. This is a line, segment, or ray that divides a segment. So I bolded that because there's another term that's has almost exact same definition, but the bold word is different. But it divides a segment into congruent parts and is perpendicular to the segment. Well, I guess just basically the segment that it's bisecting. That's what it means. So line AD right here is going to be the perpendicular bisector. From that, label triangle ABC. Alright, well now we should be able to label some like congruent markings and stuff like that. So if it's a bisector, it will make the things equal and congruent. So we can just put dashes down here like this, showing that. You could do 2 or 3, but I'll just do 2. And then we also can say that these are right angles because if something is perpendicular to it, then we know that it will make right angles. So we at least know that these are 90. And from that, you could solve maybe if you were given some of the other angles. Like maybe if you were given that one or this one, you would be able to solve for that. Okay, next. The next thing is angle bisector. This is a line, segment, or ray that divides an angle into congruent parts. So it's like perpendicular, but instead of making it things perpendicular, it just makes the angles congruent. And when you're talking about lines that are congruent, you'll have the dashes like that. But if you're talking about angles that are, then you'll have curved lines like that. So what would this question mark be? It would also be 29 degrees if it's meaning that those are equal. And the one that would be the angle bisector is this. Altitude. But anyways, yeah, this divides an angle and the other one divides a segment. But altitude, well, it's not. We're not just talking about like how high a mountain is or something. We're talking about something else this time. So this is a segment that joins. That's a segment joining a vertex to the opposite side so that it's perpendicular to that side. That's kind of wordy, so we'll show what it looks like right here in each different kind of triangle that there is. So this is just an acute triangle. What would it look like there? Well, it would look like this. It would make that perpendicular right there. So really the difference between altitude and perpendicular bisector is that a perpendicular bisector doesn't have to start at a vertex, but it is starting at a vertex for altitude. And the vertex might not be visible to see, but it's either side of this imaginary angle. For the obtuse one, you might try to say, oh, it's this, or something like that, and here's the perpendicular. Well, it's not that. It's actually going to come outside of the angle and be like this. And yes, there'd be a right angle. So that's if there was an obtuse angle. But if there's, triangle. But if there's a right triangle, then really the size itself will be the thing right here. So, like that. There you go. We already know if we're talking about Pythagorean theorem. If there's an altitude right there, that means that it's basically just a Pythagorean triple triangle. And I already said that. What is perpendicular bisector versus altitude? I already said what that was, so don't need to do that. Final term, median. This is a segment that is joining a vertex to the midpoint of the opposite side. So draw it. What does that look like? Well, if it is a segment, we know it's going to look something like that. And if it's joining a vertex to the midpoint of the opposite side, okay. Well, the only vertexes that there are this red right here, this yellow, and this green. But which one is the one that we're going to draw the segment from? Well, it's the one that's across from where the midpoint will be. And the midpoint will be on this side that's from the red to the green dots, because we see these markings right there that mean that there is a midpoint there. So all we have to do is draw from this yellow to in between those two things right there. And then there you go. That wasn't a straight line, but, well, actually, let's see here. There must be some line tool on here. Let's see. There we go. Oh, okay. That's too big, but too bad, because that's what I'm going to do. All right. And there you go. That's all it is. That's the only thing about that one. All right, and well, I kind of lied if I said that was the last term. We still have a theorem that we need to know. But really, this theorem is all that will be important for the practice that I have on the next page. And this theorem is if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half as long. Well, if you really don't like to worry about those words, just look at what I have here. I drew, so we pretty much have a triangle right here with a triangle inside it. And we have 4 triangles that are pretty much created. 1, 2, 3, 4. But the bottom line is that I drew out this in red and blue. So the red line is going to be parallel to blue. It doesn't matter if you're like, well, maybe eventually they'll go. No, they won't, because if we know that those are mid-segments, which technically this is not labeled right, there should be this. There should be that to show that they are mid-segments. And let me see, did I do that right? Yeah. And also, 2 times the red line would equal the blue line. That's basically all this is saying. They'll be parallel, and then the shorter one is, if you multiply it by 2, you get the longer one. Alright, so here's some 5 problems that I have. You can pause the video to do them. Alright, I'll go over them now. Alright, let's see what we have here. Number 1. Identify 3 sets of parallel segments. Alright, 3 sets. I'm just going to write the answers in, pick a color. How about just, green? Because there's no other green on here yet. So the parallel ones. Well, first, let's look here. Well, we see all these markings right here. Well, the one that's across from it is going to be parallel, going back to the theorem we just went over. So these would be parallel, even if they don't look like it, because that wasn't a very good thing. So we can say CB. Okay, that is not good. CB, line CB, is parallel to DC. And then there's 2 more sets that we have. This one is going to be parallel to this one. So line CA, is going to be parallel to, is that FE? Yes, FE. Oh, and by the way, those letters look like they're out of it, but they're really referring to these points right on the end, but they just couldn't fit inside the triangle. And then the last one is going to be this and this. So we have DF, line DF, and it's parallel to line AB. That's a B. This thing tries to connect the curves, and it really is not good. Okay. That's what you should have gotten for that one. And you could flip around those letters. Alright, number 2. Find the lengths of the missing sides. Then find the perimeter of the triangle. So now we know that certain sides will be half as long as the other ones. So we at least already have some of the sides. So let's start out with this 38. It is going to be parallel to this yellow angle. 38 and the yellow angle are parallel. So you divide the 38 by 2 to get whatever the yellow will equal. And let's just call the yellow angle A. So I'm just going to say A right here. Or it's not, sorry, it's a line. I don't know. I can't really say that. Let's just call the whole thing A. I should have put letters on there. But it's going to equal 19, because that's what 38 divided by 2 is. And then, I don't know, just to make things less confusing, I'm going to just write that in case you're confused. And then the 9, or actually we'll do that last. The 28 is parallel to the purple angle. So the purple angle, that is going to be 28 divided by 2, which is 14. 14. And I don't know if this is going to cut off or anything, but if it does, remember that there's another video. So 15 minutes is how long this very good software lets me record. For free at least, but I'm not going to pay for that. Alright, 9. But this time you don't divide by 2, so the blue is not going to be 4.5. You multiply by 2 because this time it's the smaller one. So that would be 18. And then perimeter of the triangle. Well, it didn't say which one, but let's just say that it's the outside one. By the way, the outside triangle will be 2 times the inside triangle. That's something to know. So all you have to do when you're doing perimeter is add the sides. It might seem complicated, but now we can label this one as 18. Now, things aren't to scale, so even though it might look like it's like a equilateral triangle, but it's not. It's not. So let's see here. 18 plus 28 plus 38. That is 84. 84, whatever unit there is. There's not one on this one, so let's just say 84 for now. That's what you should have gotten for that. Find X for number 3. Alright. Well, first let's just focus on these 2 angles. Just try to forget everything else. Right now, we know that those are going to be parallel. And we also know that the smaller angle is going to be 2 times, the bigger angle is going to be 2 times the smaller angle. So all we have to do to set up this equation is say 2 times 3x plus 27 is going to equal, I'm running out of space here, 22x. Man, does it have to be so big? Okay, 22x minus 14. If you can't read what I'm saying, just at least, or read what I'm writing, at least you can tell what I'm saying. So then you would distribute, you would get, I'm not going to really write this all down, but you can just listen to what I say. You would get 6x plus, what is that, 54. Okay, 54. 6x plus 54. And then that would equal 22x plus, or minus 14. You would just solve from there. We already know how to solve things from the other videos, but that's what you would solve. And I do not know what you would get at the end. Let me see. Well, if you did do the work and you wanted to